Good evening, everyone. In this session, we will discuss about the chemical cell. We already discussed in the last session, but there are two ways we can use a chemical cell as we discussed. A chemical cell, basically, a chemical energy changes to electrical energy. So, chemical cell is also known as galvanic cell. So, there are two ways we can use this chemical cell. Number one, we can use acid as an electrolyte. And number two, we can use a salt solution as an electrolyte. So a chemical cell, already we discussed the working of a chemical cell. We use two metals which are having a difference in the reactivity, and the more reactive metal loses electron which travel through the circuit. So a chemical cell can, the electrolyte which we are using in a chemical cell can be an acid as an electrolyte, or it can be a salt solution as an electrolyte. There's a small difference how it works. So example, a chemical cell with acid electrolyte. So if you are using acid as an electrolyte in a chemical cell, so this is a chemical cell, and cell will only work if you use two metals which are having a difference in the reactivity. It won't work if the metal have the same reactivity. So we should always use two metals with difference in the reactivity. So example one we took as zinc, another one is copper. So we have zinc here, we have copper, and electrolyte is acid electrolyte. What is the meaning of acid electrolyte? Means it contains hydrogen ions. Acids are proton donors, or acid contain more hydrogen ions. And acids are usually aqueous, so there will be water as well. So the ions which are present in the electrolyte, because it is acid electrolyte, so the ions which are present in the solution, if I have hydrochloric acid, then it will be H ion will be there. Then there will be Cl ion and H plus ion and OH minus ion. So these are the ions present in the solution. Then we connect, say, a voltmeter or a bulb, anything can be connected. So how it works, what is the working? So which is more reactive here, zinc or copper? Which metal is more reactive? So the more reactive metal will lose electron. So which one is more reactive metal here? Zinc or copper, the two electrode which we are using here. One is made up of zinc, another one is copper. So which metal will lose electron first or turn into ion? Is it zinc or copper? When we write the reactivity series, it is potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold, and platinum. As we go down in the series, the reactivity is decreasing. So which is more reactive? When we check, we are using two metal. One is made up of zinc and the other one is a copper. So which is more reactive? Because zinc is above copper, So zinc is more reactive and copper is less reactive. So more reactive will lose electron first. So in this case, zinc is more reactive and it will lose electron first and it will turn into zinc ion. So what will be the equation for the change in the zinc? That zinc atom turn into a zinc ion by loss of 2 electron. Because it is a loss of electron, oxidation is a loss of electron, so we call that as oxidation happen. So the electrons which are lost by the zinc, they will travel through the wires, and when they travel through the wire and through this lamp, the lamp will light up and these electrons will be there on the surface of copper. So more reactive will lose electron first and the electron travel from more reactive metal to the less reactive metal. So as these electrons travel from more reactive to less reactive, now electrons are negative. What they will do, they will attract the positive ions. So the electrons attract the positive ions from solution, and the positive ion which is less reactive is able to discharge easily. So when you have the positive ion, we have zinc ion is there, hydrogen ions are there. But because hydrogen ions are less reactive, hydrogen is less reactive, so this hydrogen is able to move towards the electron, and this hydrogen ion, these hydrogen ions will gain one electron, turned into hydrogen atom. But when two hydrogen ions are there, they will gain two electron and it will form hydrogen molecule. So when hydrogen molecule is formed, hydrogen gas is formed, so we'll see bubbles. What happened to the size of the zinc electrode? That size will decrease because the number of the zinc atom is decreasing as they are converting into zinc ion. So this is what happened when we use acid as an electrolyte. Is it clear the working of a chemical cell with acid electrolyte? Any doubt? If we use a chemical cell with a salt solution as an electrolyte, so there's a small difference here. So if we use a chemical cell in which we have a salt solution as an electrolyte, so what we do, we'll take two containers and we have the electrode which are made up of two different metal, like one is made up of uh, zinc, another one is made up of copper. So this one is made up of zinc and the other one is made up of copper, and we connect them with the wires. It can be a lamp here, it can be a voltmeter, anything. Now what about the solutions? So because we are using the electrolyte should be a salt solution, so one is there in a zinc solution, another one is there in a copper solution. So this is zinc salt solution, whereas the other one is the copper salt solution. So it can be any copper salt solution, but because all nitrates are soluble, so we prefer to use nitrate salt. So this can be zinc nitrate and this can be copper nitrate. But even copper sulfate can be used here because copper sulfate is also a soluble salt. So what are the ions present here? It contains zinc ion, zinc is +2. It contains nitrate ion, it contains, because these are solutions, so it contains H and OH ion. What about copper solution? It contains copper ion, it contains nitrate ion, it contains hydrogen ion as well as hydroxide ion. And these two are connected by a paper. This can be a filter paper, a moist filter paper, and we call this as a salt bridge. Basically, what is a salt bridge? Salt bridge, it's a bridge for the salt. Like the ions can travel from one solution to another. So this, if there was no salt bridge, then the circuit won't be complete. Like example, if I just only connect like this, the circuit won't be complete. There's not a closed circuit, so this will not work. So for this working, I have to take a filter paper, which is a moist or a soap filter paper, and we can just connect the two solutions and we call that as a salt bridge. So if they ask what is the purpose of the salt bridge, so salt bridge allow the ions to move from one solution to another. That's why it is called a salt bridge. Now how it works, it is working in the same manner as you can see the previously zinc and copper. So which was more reactive? Zinc was more reactive. Same thing here, what happened? More reactive will lose electron. So which one is a more reactive? So zinc is more reactive, so zinc will lose electron. So what happened here? That zinc atom, as zinc is more reactive, it will lose electron, and the equation for the solution here, electrode, zinc atom will lose electron and it will turn into zinc ions. So electrons will be there because electron cannot move in the solution, they can move through the wire. So zinc atom loses electron and it turns into a zinc ion, and these electrons travel, they transfer their energy, and then majority of electron will be here on the copper. So same way that electron travel from a more reactive metal to the less reactive metal. So zinc is losing because zinc is more reactive, so it will lose electron first, and these electron will travel from more reactive to less reactive. And then what happened? Because electrons attract the positive ions, so the electrons which are there at the less reactive metal surface, they will attract the positive ions. And because copper is a less reactive positive ion, so this copper ion will move towards the electrode, and as this copper ion will move towards the electrode, the copper ion will take electron and it turn into a copper atom. So as it turned into a copper atom, it will stick to the copper electrode. So size of this copper will increase and the size of the zinc will decrease. Is it clear? The electrolytic cell, this is also a cell, same way, but the only difference between the two, the first one we were using acid as an electrolyte, but the second case we are using salt solution as an electrolyte. Is it clear, this explanation of a chemical cell which is using salt solution as an electrolyte? Anyone having a doubt? Any question or a doubt related to this? So now we'll do some questions related to the chemical cell. Okay. In this question, so a when rods of zinc and copper are placed into a dilute sulfuric acid, as shown, the electricity is generated. So we have zinc rod and we have the copper rod. And we know zinc is more reactive. When we work out the reactivity, zinc is more reactive than copper. And this is the acid electrolyte. So what happened in acid electrolyte? What are the ions present? Because it's a sulfuric acid, so sulfuric acid contain hydrogen ion, sulfate ions, hydrogen ion, and hydroxide. The reason why, because all acids are aqueous, so they all contain water. That's why H and OH ions will be there. Now what happened? How the reaction proceed? So zinc is more reactive. As zinc is more reactive, it will lose electron first, and it will turn into a zinc ion. So what will be the equation for zinc electrode? That zinc atom turn into a zinc ion, and it loses 2 electron, and we call this change as a reduction, uh, oxidation, because it is a loss of electron. And the electrons which are there at the surface of the zinc, these electrons travel from zinc to copper, and the electrons which are there in this, they will attract the positive ion. So positive ion is hydrogen, the less reactive positive ion. So what will be the equation at copper electrode? So hydrogen ions are there, they are attracted, they turn into hydrogen atom. But because hydrogen is a non-metal, so when two hydrogen ions are there, they will take 2 electrons and it will form a hydrogen gas. So due to formation of hydrogen gas, we will see bubbles here, and the size of the zinc electrode will decrease. But in case of copper electrode, there will be no change. Why no change? Only we'll see bubbles formed. Why there is no change in the size? Because the metal is not extracted. In this example, that's why no change in size, but we'll only observe bubbles. So now the question is, write ionic half equation for the reaction that occur at zinc. So what is the reaction that occur at zinc electrode? So basically zinc, which is more reactive, will lose electron and it turn into zinc ion. Why it is of 2 marks? One is for mentioning, that zinc atom is there, and the second one is for mentioning zinc atom change to ion is 1 mark, and the electron, when you mention with a balance, it will give you the second mark. Then write a ionic half equation for copper electrode. So what happened for copper electrode? As we already discussed, that hydrogen ions will be there, they are attracted towards the copper electrode. So hydrogen ions, they will gain electron, they will turn into hydrogen atom. If two are there, they will take 2 electrons and form hydrogen gas. The copper rod is replaced by iron. Suggest the change on intensity of the light and give a reason. So what they did here, instead of using a copper, they replace this copper by iron. So when we write the reactivity series, which is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, platinum. So first we were using zinc and copper. Now we are using zinc and iron. The copper rod is replaced by iron one. The question is, what will be the effect? The brightness of the bulb. If I use an iron rod instead of copper, it will be, the brightness will increase or decrease the intensity of the light. If we are using zinc and iron, less, like a smaller difference in the reactivity compared to zinc and copper. So the voltage produced depends on the difference in the reactivity. Greater difference means more voltage. Yeah, that's right, it will be dim. So this will be more voltage, it will be bright, but this zinc and iron, small differences there, so it will produce less voltage, that is dim. So they ask two things. Number one, what will happen to brightness of a lamp? And then what is the reason? You will mention the difference in the reactivity of zinc and iron is less. That's why, compared to zinc and copper, that's why the voltage decreases. So here suggests the change, it will decrease the brightness. And the reason is that because smaller difference in reactivity of zinc and iron. Okay, another question. Three cells are set up using two metals, each up using two metals. Zinc and copper is there, zinc and nickel is there, and copper and nickel. What we have to do, we have to write an ionic half equation for reaction occurring at zinc electrode. So whenever, always remember, when they are normally in this single electrolyte, that we use acid. So what happened at zinc electrode, as for cell 1, because we know zinc is more reactive, so zinc atom will turn into zinc ion, and the electron will travel from zinc. The majority of electron will be there on the copper, which will attract from acid, they will attract proton or hydrogen ion, so we'll see bubbles. So we have to write the ionic half equation. So what is the ionic half equation for formation, conversion of zinc atom into zinc ion? So zinc atom changes into zinc ion by loss of two electrons. Put three metals, copper, nickel, and zinc in order of the reactivity. Look, how to work out the order of the reactivity. First, between zinc and copper, the voltage is 1.1. And we know zinc is more reactive. The negative one is more reactive here. So zinc is top and copper is below, where the difference in the reactivity produce a voltage of 1.1. 1.10 or 1.1, that's the same. Then we use zinc and nickel. As zinc is negative, the same thing happens. Zinc atom turn into a zinc ion. Electron travel toward the nickel surface. So hydrogen will gain those electrons from a hydrogen gas. But when you check the difference in the reactivity, the voltage produced, it is only 0.51. So what this gives an idea? This gives an idea that the difference in the reactivity of zinc and nickel is small. That's why the voltage produced is small. Where difference is more, difference in the reactivity is more, so that's why it was producing a large voltage. So when we compare the position of zinc and nickel, so it means the nickel should be between zinc and nickel, the voltage produced is 0.51 volts. And why, like the gap between zinc and nickel is smaller as compared to zinc and copper? As we know, if there is a greater difference in the reactivity, the gap will be higher. So the voltage produced by zinc and nickel cell is a smaller voltage as compared to zinc and copper. That's why they have a smaller difference in the reactivity. So zinc will be there, then nickel, and at the last there will be copper. So when we put the metals in terms of reactivity, So the most reactive will be zinc, then we'll have nickel, and at the last it will be copper. Is it clear, this part, that how we work out the reactivity of the metal using the cells? So how we can work out the reactivity of the metal using a cell? Always remember that the difference in the reactivity is proportional to the voltage produced. So if there is a greater difference in the reactivity, the voltage produced will be higher. So first we were using zinc and copper, and then we are using zinc and nickel. So this one is zinc, copper, and we have zinc and nickel. The one which is referred as a negative terminal, that is representing more reactive metal. Same thing, a negative terminal representing it is more reactive metal. When we use zinc and copper, the voltage is 1.10. When we use zinc and nickel, the voltage is 0.51. How to work out the reactivity using the voltages? So first, zinc and copper, when we are using zinc and copper, the voltage is 1.1. So it means they have a greater difference in the reactivity. And zinc is more reactive because when we write the negative sign, we write it on the more reactive electrode. So zinc is more reactive and copper is less reactive, and the difference in the reactivity is 1.1. So this total is 1.1. Then if we use zinc and nickel, the difference, so zinc is negative, nickel is positive, it means zinc is more reactive than nickel, but the difference in the reactivity for zinc and nickel is only 0.51. So they are asking, set up the reactivity series, how we can work out which is more reactive. So at the top we have zinc, then we have nickel, and at the last we have copper. So how to work out which is more reactive, less reactive? So you can use the voltages. So more reactive is zinc, followed by nickel, and at the last it will be copper. Then complete the label of cell by writing plus and minus on the electrode. So negative sign is for more reactive electrode and positive is for less reactive. And then we have to state the voltage as well. So first, when we set up the reactivity, so we have the first one is zinc, then there is nickel and copper. Between zinc and nickel, the voltage is 0.51. Between zinc and copper, the voltage is 1.10. So how much is this voltage? Between zinc and nickel and copper, what will be this voltage? So how to work out? This is a total 1.1 from copper to zinc. And if I subtract 1.1 minus 0.51, that is equals to 0.59. So the voltage produced by nickel and copper will be 0.59 volts. So the value of the voltage will be 0.59. And what about the charges? Because we know nickel is more reactive than copper, so on nickel we'll write negative and copper will write positive. Because in a chemical cell, the more reactive electrode we represent by a negative sign, and the less reactive we represent by a positive sign. Is it clear that how we work out the voltage of a cell which consists of nickel and copper electrode? Any doubts? So another question, question 5, the diagram shows a simple cell. So as you can see, this is a simple cell which is having two metals having difference in the reactivity. The simple cell was used with different metals as electrodes. So we use different metals as electrode. The voltage were recorded. If voltage measured is positive, like if we get a positive voltage, it means they give you the hint. It means according to question, metal 2 is more reactive than metal 1. But if voltage is negative, then metal 1 is more reactive than metal 2. So the values of the voltages are given. We can set up the reactivity. Look, when I use metal 1 as beryllium, when we use metal 1 as beryllium and metal 2 as cobalt, and we are getting a negative voltage. So what is the meaning if we are getting a negative volts? If we are getting a negative volt, it means metal 1 is more reactive than metal 2. So it means beryllium is more reactive than cobalt. So beryllium will be up and cobalt will be down, and the difference in the reactivity between beryllium and cobalt, that is 1.6. Is it clear? The first part, how I work out which one is more reactive, either beryllium or cobalt, because when I use beryllium and cobalt, beryllium is metal 1 and cobalt is metal 2, and we are getting a negative answer. So if we are getting a negative answer, it means metal 1 is more reactive than metal 2. Then we use beryllium and nickel. So when we use metal 1 beryllium and metal 2 nickel, it is also producing a same voltage. So it means the difference in the reactivity of beryllium and nickel is also same as beryllium and cobalt. So we have the same position for nickel as well. Then beryllium and silver is not measured. We did not measure. And then beryllium and vanadium, that is negative, and we are getting 0.7. So if the voltage is negative, it means metal 1 is more reactive or beryllium is more reactive, and the difference in the reactivity is only 0.7. So beryllium and vanadium, the difference in the reactivity is 0.7, so it will be here. So when we try to set up the reactivity till this point, so we have beryllium, then vanadium, and then nickel and cobalt according to the first row. Is it clear? The first part, how I work out the reactivity, excluding silver, because the first row they did not mention the voltage of the silver. That's why I cannot find for silver. So when we use metal 1 and metal 2 and we are getting a negative voltage, according to the question, the metal 1 is more reactive than metal 2. And if we use a cobalt and silver, metal 1 is cobalt and metal 2 is silver, so we are getting a negative voltage. So what does it mean, negative voltage? It means that cobalt or metal 1 is more reactive. So cobalt is more reactive than silver, and the difference in the reactivity is 1.1. So this will be 1.1 volts, and silver is less reactive and cobalt is more. So what is the reactivity series? According to the metals which are given, it will be beryllium, vanadium, nickel, cobalt, and silver. So this was not the question. Now we'll move on to the question. So first part, we have to define oxidation in terms of electron. Oxidation is the loss of electron. When something loses electron, we call oxidation. Nickel form ion with a +2 charge. Write an ionic half equation for oxidation of nickel. Oxidation means loss of electrons for nickel. So we have a nickel atom. It changes into nickel ion by loss of 2 electron. What will happen to the mass of nickel electrode? Because when atom changes into ion, ions will enter the solution, so the mass will decrease. So there will be a decrease in the mass of the nickel. Then use your data. Which metal in the table is the most reactive? So we already work out that is beryllium. And why it is? Because it is always a negative voltage. So it is producing a negative voltage every time. That's why it is a more reactive. Which two different metals have the same reactivity? That is nickel and cobalt, because they are producing the same voltage with beryllium. So nickel and cobalt. Predict the voltage for beryllium and silver. So how we can work out? Beryllium was there, vanadium, nickel, chromium and silver. So here it was 1.1, and from beryllium to nickel it was from beryllium to nickel and cobalt it was 1.6. So this will be 1.6. So what is the voltage produced? It will be 1. So in this question, we have to work out the voltage when we use beryllium and silver. So how we can work out the voltage produced when beryllium and silver? As you can read the first the line, that if voltage is negative, the metal 1 is more reactive than metal 2. So beryllium and cobalt, like when we use one metal as metal 1 is beryllium and metal 2 as cobalt, the voltage is 1.6 or minus 1.6. When we use beryllium and nickel, the voltage is also minus 1.6, so it means cobalt and nickel have the same reactivity. Beryllium and silver is not measured, and beryllium and vanadium is minus 0.5. So when we use beryllium and vanadium, so the voltage is minus 0.7 volts. If we use cobalt and silver, like when we measure cobalt and silver, so that voltage, because negative voltage means metal 1 is more reactive, so it means cobalt is more reactive than silver. So silver will be below and cobalt will be up, and the voltage is minus 1.1. So the question is, what is the voltage produced when beryllium mixed with silver? Like if we use an electrode made up of beryllium, another one is silver. So beryllium to silver, because from beryllium to cobalt it is minus 1.6 and cobalt to silver it is minus 1.1. So total voltage will be minus 2.7 volts. So if we use a cell which is having one electrode as beryllium and another one is silver, then what is the voltage produced by this cell? It will be negative 2.7 volts. And describe how a simple cell can be used to show that magnesium is more reactive than beryllium. So how we can work out whether magnesium is more reactive than beryllium? So we will use one electrode made of magnesium and or metal 1 electrode made up of magnesium, and the second electrode made of beryllium. If it produce negative voltage, It means magnesium more reactive than beryllium. Is it clear? Discussion about the chemical cell. The question was, the last part was how we can work out that whether a beryllium is more reactive than magnesium is more reactive than beryllium. So we will take both electrodes, one made up of magnesium, the other one is beryllium, and it should produce a negative voltage. So this was a question related to a chemical cell.